Good evening, everyone. Welcome to week 7 of Data Science for Engineers course. I am Elsa Sharu Johnson from NIT Tiruchirappalli. So this week we had looked mainly on logistic regression, and we had looked at certain parameters, performance parameters, and its implementation in RStudio. So in this week, the major questions, the major part of the assignment question deals with the implementation of the data set which is given in RStudio, and some of the questions are based on the theory. So we'll start with the assignment questions of July 2023 session. Okay. So the question is first to load the dataset iris.csv as a data frame iris_data with the first column as index headers, first row as column headers, dependent variable as factor variable, and answer the following questions. So in between, any questions you have, you can put in the chat window. Okay. So I'll just move on to the window which has the data set. So data set is like this iris.csv. I'll just expand that and show you. So this particular data set has first column as an ID and first row as the column headers, and then they have given like dependent variable as factor variable and answer the following questions. So we have to load the dependent variable as a factor variable. That is important. So after that, after loading, we have to look at the following questions. So in this data set, it contains 4 sepal and petal features given as sepal length, sepal width, petal length and petal width, all in centimeters, of 50 equal samples of 3 different species of iris flower. So this you have seen already, you might have seen already. So these are the features that are given. This last column is the species column. So anyway, we have to load this to our environment. So for that, I will first load it. So we have to load it to iris_data. So I'll use the read.csv command, and I have mentioned the place where the file is available. Then I'm giving header equal to true, row.names as ID. Okay, since we have asked to give the first column as index headers, that's why we are putting row.names equal to ID. And then we have also been asked to put the dependent variable as a factor variable, which was the species column. So for that, I am putting string as factors equal to true. So it will automatically convert it to factors, or you can say that it will automatically convert those strings to categories. It will take as categorical variables. So like that I have given, and if I load this data, I am getting this particular iris_data. So you can see here, earlier when we checked this one, we had ID column. Okay, so we had taken it like the first column we have given like row.names equal to ID we had given. So that is automatically taken as the name of the or index of the different entries, and so that column is now not available here. The index itself is taken as row.names, and then the sepal length, sepal width, petal width and species is there. Okay, so then now next, after loading this data, now we will look at the different dimension as well as the type of data which is present. So first we will put dim of iris_data. So it shows us that there are 150 rows and 5 columns, and then if we give str of iris data, it will show like this. So these details are available. Sepal length, it is given like numerical value, sepal width numerical value, petal length and petal width numerical value, and species is taken as a factor. So just for an example, if I just take the same loading of data, and just if I remove that extra argument that we had given here, like string dot factors equal to true, if I have removed that, then with that I am again running the str. So here you can see, if I haven't specified to the species column to be read as a factor, then it will be automatically be read as a character, okay, because it's actually a character. These are character variables, right? So if we don't mention it as factors, then it will be read as character only, and the model won't recognize it as something to be a dependent variable or something to be classified. So for that only we are specifically mentioning it as factors, okay. So what I'll do is like I'll load the data again. So I'll clear the environment and load those data again. So now you can see species is again given as a factor. So the initial things we have specified, and now I am going back to the question. So in the question, first it is asked what are the dimensions of the data frame. You have already seen that one, 150, 5. Okay, so that are the dimensions. Those are the dimensions. So I have just given a snippet of the code also. So any one of you are having the code and the data with you, you can just follow me when I am doing this program, okay. Just you have to give iris underscore data equal to read.csv wherever you have given your data, okay. So this is another snippet for another path actually. So wherever you have kept your file, you have to put that particular path here, and all the things remaining you have to keep it like this. So okay, so we'll move on to the next question. What can you comment on the distribution of the independent variables in the data frame? Okay, so maybe if someone of you are already familiar with this one, you can give the answer, or otherwise I will just move on to the RStudio. Okay, so question 2 is, what can you comment on the distribution of the independent variables in the data frame? So independent variables, there are 4 independent variables: sepal length, sepal width, petal length, and petal width, okay. So for seeing the distribution, there are many ways. One thing you can do is see the summary of the data, iris underscore data, and from the summary you can see either the mean or median, okay. So for seeing the mean or median, I will put summary of iris underscore data, and from that just I will increase this figure, okay. So here you can see for sepal length, okay, you can closely observe this one. The median value is 5.8 and mean value is 5.843, okay. For sepal width, it is 3.00 and mean value is 3.057. Then petal length 4.3 and 3.7, so it's like a great difference is there. And petal width, median and mean in this way, and species anyway, those are classes, okay. So from this, if you look at this sepal length, sepal width and all, you can see that sepal length, the difference between the mean and median for sepal length is very small. It is like 0.43 difference only is coming. For sepal width also, there is only a 0.057 difference. So from that you can say that in this one, just I will take this, yeah. So we have found out that for the first one, sepal length, difference between mean and median, difference between mean and median is 0.04 3 0.043, and for sepal width it is 0.057. okay, so that we have found. Now the other thing is, so the other thing we have to look is petal length. The difference is like there is actually this is like a more significant difference, right? If you see that there is about, you can say 0.5 difference will be coming, about 0.5 something. And petal width also there is like 0.2 difference. The other one was like it was 0.043 and 0.057. it is higher for the other two things. So from this itself you can say that if your distributions mean and median are closer to each other, you can say that there is a normal distribution. okay, so from that itself you can say the first option is wrong. All the variables are not normally distributed. Why? Because for the other things, petal length and petal width, the difference is high. okay, so from that itself you can say that all variables are not normally distributed. The second thing is like the variables sepal length and sepal width are not normally distributed. This is also false, because the variables which we can tell as being normally distributed are these two variables only. okay, so this is also not true. Then the variable petal length alone is normally distributed is also not true. So like one of you have answered yes, the option will be none of the above. okay, so this is one of the methods. So in your exam you will not be accessing the RStudio, but you will be having certain like clues like this. So if you are given with a data set and you are given the mean and median values of all the variables in that, and then you are asked to find out which one are normally distributed or something like that, you can get the questions. So in that way, if you ask, this is one of the methods in which you can tell that this one is normally distributed, the other two variables are not normally distributed. So this is one of the methods. Another method is from the plot. okay, you can also plot the specific variables and see whether they are normally distributed or not. okay, so for plotting I require 2 extra libraries. So this is not usually seen in RStudio. You have to install them first. So I have already installed that. So if I just see the packages, in the packages if I just put ggplot, it's already there, ggplot2, and ggalley is an extension to the ggplot. okay, so both this, if it's present, you can have most of the visualizations done. okay, so usually we'll install both these together. So then after installing the packages to include them in our environment, I'll be putting library of ggplot2 and library of ggalley. okay, so both these I have included, and after including that I'll be doing a pair plot. So what a pair plot does is that I'll be having the set of variables like this. okay, there is a section like this, and the sepal width, sepal length, sepal width, petal length and petal width will be plotted, and here also it will be there. okay, and you will see the distribution between each one of them. okay, I'll just mark 1 2 3 4 for the other one, and you'll see the distribution, and the diagonals will show you the distribution between the same variables, or it will say how your particular data is distributed for that particular variable. okay, so for that just we'll move on to the RStudio, and I'll just run this particular code, gg pairs of iris data. So it will take some time, and the plot is now visible. okay, So this is the ggplot which can be drawn with that particular command. So here you can see the two things which like kind of resembles a normal distribution is, you can see from here itself, sepal length and sepal width. Okay, petal length, if you see, it is like 2 maxima and 1 minima are there, and this is not a normal distribution, right? And petal width also, you can see, doesn't give a normal distribution. Okay, so from here itself, some chance of being normal distributed are these two actually. Okay, this is like a wider distribution, and this is like a narrow distribution is there. So sepal length and sepal width will be normally distributed. Now looking at this pair plot again, we can see that this will be sepal length and this will also be sepal length. So this is the distribution. In the right hand side, in this side it has come. Okay, just if you see, this is the different variables and this is the other axis where it is distributed. And if you want to find out the distribution between sepal width and sepal length, you can look at here. Okay, so here the pattern will show you how correlated are these variables. So in this particular pair plot, the diagonal elements will show you how the distribution is. So you can see the species will show you how the distribution is like. So for example, for Setosa there are 50 entries, for versicolor 50 entries, and virginica 50 entries. Okay, then the upper diagonal portion will show the correlation between the variables, and the lower diagonal portion will show the plots. Okay, the scatter plots between the two variables. Then there also you can see the box plots for all these. So for Setosa, how the distribution is done. So from this plot, okay, so for example, for sepal length for Setosa species, you can see that there are two outliers present, right? So from this whole plot, there can be many observations drawn from this particular plot. Okay, so this is it's a plot which is very helpful for you to visualize. So anyway, we'll go back. So from the ggplot also we have found out which one is better. Now I'll move on to the next one. Any questions you can ask right now, or I'll move on to the next one. Okay, so I've just put a code snippet also. So here just you can see that this one as well as for this one, the distribution is different here from the one which I've shown here, because okay, so because there is some difference in the data. Now how many rows in the data set contain missing values? Okay, so for that we have to see another argument like is NA. Okay, is there missing values or not? So this I have written. So is.na is the function, and I will be applying it to iris_data, and simply if you give is_na, it will be showing you like true or false. Okay, so that also we will just see, and later we will look at the sum of the missing values. So now I have just given is.na of iris data, then it will give false. Questions in the assignment will not be just from the assignment. Okay, questions in the exam will not be just from the assignment. Different questions will be there. It will include all that you have learned. Okay, yeah. So this will show you where any instances, if you get true, that means that in that particular row you have some kind of missing values. But if you are giving like sum of is_na of iris data, then it will be summing and showing you whether there is any missing values or not. So for that I have got 0 missing values. So that is the answer. Okay, so I've given that code snippet also. Now what can be interpreted from the plot shown below? I think you can just see the plot here. This plot is kind of a big plot only, so I think you can just see how what you can infer from this. Okay, so you can put the answers in the chat window. So actually we should be looking at the sepal width, because the plot given is between sepal width and sepal length. Okay, so the options are also coming like that. Sepal length, it's speaking either about the sepal length or sepal width of different species. So you can just look at the plot and draw the conclusion. So I'll start with the first one. Sepal width of versicolor flowers are lesser than 3 centimeter. So if you look at that, so sepal width is shown. Okay, one I am getting B and I am getting another answer as D. Okay, you can just keep on checking. So sepal width of versicolor flowers are lesser than 3 centimeter. Versicolor is denoted by green, so it's lesser than 3, it's not there. Okay, the next one, sepal lengths of setos of flowers, so I'm getting B and D also. Okay, so anyway we'll look at that. Sepal length of setos of flowers are lesser than 6 centimeters, so sepal length setosa, that is less than 6, that is true. So this is like a scatter plot. Okay, then sepal length of virginica flowers are greater than 6 centimeter. It's not just greater than, less than also there, so it's wrong. And sepals of setosa flowers are relatively more wider than virginica. So width of setosa compared to the versicolor. Okay, actually that is true, right? Because the green things are lying below this red color setosa, so that is also true. So the answers will be B as well as D. Okay, so you can include both these answers. Both these answers are right, not just one answer is true. I hope it's clear. For those who have given one answer. So based on the given plot, it can be seen that setosa flowers have wider sepals compared to versicolor and virginica flowers. Also sepal length of setosa flowers are less than 6 centimeters. So because of that, we can give both these answers. Okay, I hope it's clear with you. We'll move on to the next question. Which of the following code blocks can be used to summarize the data, finding the mean of columns, petal length and petal width, similar to the one given below? So this one, we'll look at all the options. If anyone knows the answer, you can put in the chat window. Otherwise we'll start with every option that is given. Okay, so first one, question 5 was asked like, which of the following code blocks can be used to summarize the data? Okay, so the question is to summarize the data. So initial summarize, if you want to try for the whole data set, you can use the summary of iris data that we had already seen, summary of iris underscore data. But that is not the question now. We are just asked to find the mean of columns, petal length and petal width. Okay, so for that what you can do, so I've got the answers A and D. Anyone having any different answers? Okay, anyway we'll see. Okay, we'll see the RStudio ones. All right, so I'm first starting with option D. Okay, in option D it's written apply of iris data 3 to 4. Okay, so because it's like 1 2 3 4, 3 and 4 are the columns. All right, so 3 to 4, 1 and mean. Can anyone put which of the where this particular function will be applied? means this apply function is actually used to do a particular operation. So mean is already defined in RStudio, so this mean will for this particular columns which are told, the mean will be applied. Okay, but in this particular argument there is a difference based on the value 1 or 2. Okay, so with that, in our option it is like given in the option D, it is given like iris data 3 to 4 comma 3 to 4, it's given 1 mean. So for that result, if this is 1, okay, you will be getting the mean for each row actually. Okay, actually you want to find the mean for columns, petal length and petal width. That means like column wise mean you have to find out. Okay, but here if you give like 1, you'll be getting the row wise mean. Just I'll run that and show you. So here you can see, if I run this particular thing, okay, apply like this, if I am running, you can see that for the particular columns that I've given, right? Okay, for the first row I'll get mean 0.80, for the second row I'll get 0.80, for the third row 0.75. That means that these two columns are there, petal length and petal width, and the mean of 1.4 and 1.2 is coming like 0.8, right? So 0.8 was displayed. Then mean of 1.4 and 0.2 is again 0.8. 1.3 and 0.2 will be coming like, which one was given here? Okay, 1.5, so it will be coming like 0.75. So I hope you understood. If you are giving 1, it will be doing a row wise operation, and if I am doing the column wise operation, if I have to get the column wise operation, then you have to do, or you have to give 2. Okay, this is actually same for most of the operation that we do, row wise, column wise operations that we do. So if I give 2 only, I will get the answer. So since I had given, so in our question, this one, it gives a row wise operation, which is not our answer, so it's eliminated. The second one, apply iris underscore data, this one 2 comma mean, it gives the correct answer, so we can put C is one of the answer. Okay, C is one of the answer. Now we'll move on to option B. So in option B we have S apply. This is a different function. Okay, the same kind of operation will be done, but we'll see what is the difference happening here. So S apply iris underscore data 3 to 4 to mean. Okay, it's given like that, but whatever was given in the question is a wrong syntax. Okay, so if you are using S apply for iris data for these columns, you don't have to specify which is, should it be a row wise or a column wise operation, because S apply is usually done for columns only, to find the mean of columns. So for that, so if you run like this, it will give you a syntax error. Okay, so the correct syntax for getting the mean should be like, you have to remove the 2, but in our option it was there, so B is wrong. Okay, B option is also wrong. Now the next one, L apply. Okay, option A, L apply. L apply is another function. So if you are using L apply iris underscore data mean, if you are giving like that, you will be getting a different kind of display. Like earlier it was like petal length mean, petal width mean. Okay, here also it is given like this only, but the display is different. Only the mean only will be displayed. Okay, you can see here the mean only is displayed, but the type of display is different, but anyway that is accepted. So you can say that L apply is also true. So the answers for this particular question is A and C. Okay, it's not D, A and C. So I have given the answers of each and every option. Okay, so the answer is A and C. So we'll move on to the next question. Which of the following packages must be imported to use the logistic regression function GLM? You can give the answer. I am getting B. Actually DPLYR is not required actually, because GLM is already present. Okay, actually we don't require any extra packages. It's an inbuilt function available in R. Okay, DPLYR we have used last class. So for GLM it's already available. Okay, so the answer is D actually. I hope that's clear. Okay, now encode the dependent variable species, split the given data set iris underscore data into training and test sets in the ratio 7:3 with the seed value as 123. Apply the logistic regression model in the training set. Okay, so it's kind of a connected question, and we are asked with which of the following parameters are significant with 95% confidence interval. Okay, so question 7. Okay, so for this, the first thing given is that encode the dependent variable species. So last time itself I told, for encoding first we have to take it as a factor. Okay, so that is important. Then the splitting of the given data set into with the ratio 7:3, and then we have to give a seed value to restrict the randomization. So seed value should be given as 123, and we have to apply the logistic regression model. Okay, so for that I'll come back to this one. Just I'll remove all the variables right now which are available. So first I have given two options here right now. So first one is read.csv file.choose header equal to true, row.names equal to id, string as factors equal to true. This we have already seen. So if you want to have your categorical variable as a factor and not as a character. Okay, so if it's just taken as a character, it won't recognize that it should be a categorical variable. So first you have to give this particular option, string as factors as equal to true. So anyway, I have given two of them. First I have loaded iris underscore data, like the categorical column or the dependent column encoded as factors, and the next one I haven't done anything, and I have stored it as iris underscore 1. Okay, so okay, just wait a moment. So we are asked to find out which of the following parameters are significant with 95% confidence interval. So this is like being cleared only. So first, anyway, yeah. So first I have to choose the file, right? So it has come here. So here iris underscore csv, this is loaded, and species is available, which is a factor with 3 levels. Okay, now again I'll be loading iris underscore data, and this one again I'll be taking from here, and I'll be loading it the same thing only, but I am not loading it as a factor. So here you can see species as a character. I think you can, it is displayed right now, right? You can see when I place hover over the character, hover over the species, it is kind of displaying character, right? Okay, so Okay, now what I'll do is like for splitting and all we require another library, so I'm importing that library, CA tools. Okay, now just wait a moment. Okay, so we have loaded two types like iris underscore data and iris1 underscore data. Okay, anyway we'll see both them. So set dot seed, we have to set a seed with the value 123. So for that I'm putting set dot seed 123. Okay, so then what I'll do is like I'll split the data. Okay, so first I'll split the data with respect to iris1 underscore data for the species column. Okay, based on the species column I'll be splitting, and the split ratio is 0.7. then if I do, it is coming. Okay, but if you see, it is like a logic. Okay, now if I just see the split data, okay, if I just see this split data, now it's coming in this way, true false like that. Is there any raised hand? Shishir, do you want to ask something? Okay, anyway we'll see both. So right now I have done split data, and split data is coming in this way. Okay, then one more time I will just, okay, so with this one, so right now I have loaded the iris underscore 1. Okay, so then if I split like that with respect to iris underscore data, so for this one, anyway I had already loaded it with this one, right? So split underscore data is already this one, and if I do this, it is coming like this way. And train underscore iris underscore data, I am giving like subset of iris underscore data split underscore data equal to true. So wherever the split data was coming as true, it will be given on to the train set. Okay, so I am doing that, I am running that particular line, and then if I see the dimension, it is coming like 105 rows and 5 columns. Now again I am doing like test underscore iris data subset split data equal to false. So if I run this particular thing, and if I see the dimension, it is coming like 45.5. So it's kind of matching, right? 105 plus 45 again will give 150. So it has split it like 70% training set and 30% test set. Okay, now I am converting. So they have asked us to put, or you have to encode the variable species. So right now we have converted it as a factor. It's like a categorical variable right now. Now we have to encode it, right? So for encoding, I am doing like train underscore iris underscore data species, I am giving as dot numeric. Okay, so whatever factors is there, it will be converted to 0, 1, 2, 3 form. Okay, so train iris underscore data, if I see, now you can see that species are coming like 1 and 2 and 3, right? It's coming like in this way. Now again, so test iris right now is like this. You can see setosa, versicolor and virginica. Now if I do this as dot numeric operation to test data, that also will be coming like this, species 1, 2, 3. Okay, so now we have encoded, so we have split the data, we have encoded it, and we have set the seed. So all the initial things are done, and now we will be doing the logistic regression model. So I am giving logit underscore model glm. Okay, species sepal length plus sepal width plus petal length plus petal width, data is equal to train iris dot data. So I have given this one, right? And summary logit model. So you can see here whatever the parameters that you had seen in your lectures for logistic regression model, that is right here now. So glm formula equal to species, which is related with sepal length plus sepal width plus petal length plus petal width. Data is taken from train iris data. Then so we have asked to find out which of the following parameters are significant with a 95% confidence interval. So that we have to find out. So here you can see, so all the other data, residual data, then coefficient, the estimate, then standard deviation, then the t value and the probability, everything is given, and you can see certain asterisks given here. Okay, so these asterisks correspond to the significance code, and you can see that these asterisks are present for the intercept and petal length and petal width. Okay, for sepal length and sepal width it's not there, meaning like the significant code is like around 1. Okay, then again you can see other things like deviance with this much degrees of freedom and 100 degrees of freedom, like including, so it was like 105, right? So just including the intercept it is this much, and including all others is this much. Then number of fishes scoring iterations, this one. Okay, so all these things you have already seen, right? So just looking at this one, just looking at the significance code, you can find out which one is not significant, right? So here from this one itself you can see that sepal length as well as sepal width are not significant. Okay, they are like, I mean, if you say in the hypothesis these are like these two variables will come equal to 0, which means that it is not significant. Here intercept, petal length and petal width, they are like significant variables. So in this particular question this one is not significant, and you can say the other 3 are like significant. Okay, so this is the snippet for doing the particular question, and I've given the full thing. Okay, so from the given summary of the model applied on the training data, it can be observed that the parameters petal width, petal length and intercept are significant variable as their p-value are lesser than the confidence interval for alpha value equal to 0.05. The p-value, if you see, that also is less. Okay, so any questions in this one?
Ma'am, good evening.
Yes.
Ma'am, I'm in my R studio. I'm not able to install certain library. For example, the CA tools. What is the reason, ma'am? Actually,
How have you installed that one? How have you tried installing? Means are you installing it through the package install, or are you trying any other method? So right now if I do like CA tools, if I do, it's already installed. Okay, so just in the packages you just check if it's listed or not.
ma'am, how to check actually the package, ma'am? Actually,
Okay, just
I'm
I'll
new to R.
okay. So right now this package is
Okay,
not here. Okay,
here.
CA tools. I have removed the package. Okay, so
Okay,
what I'll
okay.
do is like I will, this is one of the methods. Okay, directly you can do from the
Okay,
environment
ma'am.
itself, but here it's better to do like this.
Okay, ma'am.
So install from repository cran. Okay, and ca tools is present, and install to library. Where is your path? You can, I mean, it will already come, but there you can install. And you have to check install dependencies also, and then you can give the install option. Okay, then yes,
Okay, ma'am. Okay.
yeah, just try this once if you are getting.
Okay. Ma'am, can you repeat once more, ma'am? I have some network connections, please.
Okay, okay, so right now if you are not having this, so just search in packages, you can just search for the package that you require. So the first one is ca tools. Okay, that you have asked. So that one, now right now it's not available in my environment, so I'll just put that name. It's already there. Okay, I mean in the repository, so I will put that name, and then I'll give the installation path, and I'll give install dependencies also. Then I'll give install, then I'll give yes. Okay, so first it will
Okay,
restart
ma'am. Okay.
R, yeah, and it will load the package. Then after it is loaded, it will show. Okay, if you search like this, okay, so if it's not there, so packages that are installed currently in your environment will be shown here, and if you just search for that, you can see that ca tools is available. Okay, so right now it's there in your system. Now if you want to include that, you have to give library of ca tools, then only it will come to your specific execution environment, then only you can do the other options. Okay, so I hope it's clear. So anything you want to see more on this one, you can just go to this particular link. Okay, just I will see if it's available. This particular link. Okay, so this one I have given like what are the different codes. Okay, generalized linear models in R, understanding model fit. Okay, this is the thing. Okay, so for that I have just searched for Fisher scoring algorithm. This I think you have seen in your lectures also. It's a derivative of Newton's method for solving maximum likelihood problems numerically. Okay, then all the different things are given, which is usually you'll see in a glm command. Okay, so generalized model on linear data, this is the one. So its original thing is documentation can be seen here. Okay, so glm parameters, generalized linear model. Okay, so it will show you what is the distribution and all. We'll come to this later. So this information I have given in this link. Okay, you can follow this link and see. Okay, now we'll come back to the next one. What is the coefficient of the variable sepal width in the fitted model? So again, it's a question based on the summary itself. So it is asking, so I think the summary is given, yeah, the summary is here. So we are asked like what is the coefficient of the variable sepal width. So this is the coefficient. Okay, so it's given, so whichever is nearer to the other one you can just select. Okay, so here Actually there is a change in the values. Okay, so anyway, I'll load the data once again and we will see that. So iris underscore data, so iris underscore csv data, and then I will run all these things. So the summary, it's coming like this. Okay, 0.069. so here in this one, the coefficient of the variable sepal width earlier was, I mean when the question was done, it was coming like 0.1311. okay, that's why it's written. So now if you look at this one, the coefficient is coming like, sepal width is coming like minus 0.06926. okay, this has happened because the seed and the randomization has changed right now with the package. Okay, so if you are getting the similar answer like I am getting, it's okay. So the, in this particular case, the, in the question 8, which is like what is the sepal width, the coefficient of the variable sepal width in the fitted model is right now 0.06926. okay, yes, any doubts with that? Okay, I hope there are no doubts. We'll move on to the next question. State whether the following statement is true or false. Logistic regression tends to overfit when we have large number of independent variables present. Is it true or false? What's the answer for this one? You can just put, I will just put, yeah, true I have got. Okay, so I hope all of you are having the same answer. So this is true. Okay, so the thing is like, logistic regression tends to overfit when we have large number of independent variables present. I have got a false value also. The thing is like, Neil, if you have many variables, some of the variables only might be required to get an optimal solution. Okay, so that is why we are having feature selection techniques and all, to select the optimal number of features which are required. If you have a large number of features, your training set might be very well trained on the model, with the model, but your test set might not be giving good accuracy, which will lead to overfitting problem. Okay, so the answer is true. I hope you are clear with that. Okay, now an ROC curve is plotted between, you can tell A, B, C or D. Okay, I've got B from everyone. Yeah, that is true. So it is like a curve between, so a curve drawn, and you can see divisions like this. Okay, so sensitivity denoted by SC and specificity denoted by SP. So here it is 1 minus SP. Okay, this you have seen in your lecture, right? If you are decreasing, if sensitivity is more, the specificity will be less, so you have to have a trade-off between that. So sensitivity, specificity, actually everything. So the area under the curve, okay, so there is a line in between. The line under that curve is actually 0.5. So the total area under the curve, that is given as area under the curve, or receiver operating characteristics area under the curve. Okay, so this, if it's like between 0.8 to 1, then you can say that you have got a very good model, classification model. Okay, then if it's lesser than that, your model prediction is not good. Okay, so this is another metric which shows you whether your model is a good model or not. So an ROC curve can be plotted between sensitivity and 1 minus specificity, or it's given like the true positive rate and false positive rate to determine the better classifier that actually predicts the classes. So okay, so these are the 10 questions which were given in the July 2023 session. So we'll have some practice questions. Which one of the following is called as the odds ratio? You can give the answer for A, B, C, D. So what was odds ratio? I've got the answer A. Okay, anyone has any different answers? So the probability of event occurring, I can give P of x, and probability of event not occurring can be 1 minus P of x. So actually odds ratio is given like P of x by 1 minus P of x. Okay, so the ratio of probability of an event occurring to the probability of event not occurring can be given as odds ratio. So the answer A is correct. Okay, in confusion matrix, the mixed classification rate is given by. So confusion matrix was discussed earlier itself. Okay, and in your present lectures also it was there. So if I have a binary classification problem, so the predicted, if it is like this, okay, if the predicted values are like this and actual values are here, or the reference values, okay, now if it's 0 1 0 1, if so, you can take this as, I mean, negative, this as positive, this as negative, and this as positive. Okay, so if you consider in that way, if it's predicted negative and actually negative, you can say that truly negative. If it's predicted positive and actually positive, you can say that it is true positive. Okay, then if it's truly negative but predicted positive, you can say that it is false positive, and if it's truly positive and predicted negative, you can say that it is false negative. Okay, so I've given an answer, I've got an answer like B. Okay, so yeah, we will go to that. So accuracy is given like all the correct classification by the total number. So N is given by Tn plus Fn plus Fp plus Tp, true positive, false negative, true negative, and the accuracy will be given by N, total number of samples, and this is like true positive plus true negative. Misclassification is kind of, you can say like 1 minus accuracy, or you can say like what are the misclassified samples. So misclassifications are given by false positive plus false negative. Okay, so the answer will be false negative plus false positive by total number of samples. So the answer is A. Okay, Is everyone clear with that? Okay then. Okay, so the answer is A. Okay, so I've given this one. Next one, the value of both sensitivity and specificity lies between. I've got answer D. Okay, yeah, that is true. So anyway, the highest value that it can reach is close to 1, or it is 1, and the lowest value is 0. So if your model value, if the sensitivity and specificity value lies close to 1, that is a good model. I mean, it's a good performance metric, better performance metric, denoting a good model. Okay, and also sensitivity denoted by SE right now is given by the number of true positives per positive classes in a particular set of samples. Okay, so the positive samples in a particular case is given by true positive plus false negative, falsely predicted as negative. Those are all positive classes only, and true positive is already positive classes only. Okay, so how many of the predictions, how many of the positive predictions has been classified correctly will be given by the sensitivity. Okay, so it's given by true positive plus false negative, and specificity is like in positive predictions how many are positive. So in specificity it is like positive, if positive predictions are this much, okay, in that how many are really positive. Okay, so that will be denoted by what all are the positive prediction. True positive is truly positive as well as predicted positive, and false positive is also like prediction is positive but actually it is negative. So the number of positive predictions will be denoted by TP plus FP, and in that how many are truly positive will be denoted by TP. So specificity is TP by TP plus FP. Okay, so anyway, both these values should lie between 0 and 1. Next question, in logistic regression, a linear relationship is assumed between the independent variables and, you can give the answer. Usually how the relationship is given, there are a set of independent variables and you will have, okay, log of dependent variable, a sigmoid of dependent variable. Okay, actually this is like a tricky question, okay, because what have we been defined actually in logistic regression? What is actually logistic regression? It relates the log odds actually. It's not log of dependent variable, all right. Just go through your notes once more. Okay, so those people who are giving A, okay, the relationship between dependent and independent variable are not log here. Okay, if you see, your relationship was like log of p of x by 1 minus p of x. That is the log odds ratio that is related to your normal beta naught plus beta 1 x. Okay, if you just say it like, if this should have been the option, it would have been like log of your dependent variable denoted by y, you can say it is equal to your independent variable. Okay, but this is not the relation that we are having. We are having the relation between the log odds ratio. Okay, so earlier in linear regression it was like y equal to y, which is the dependent variable, is equal to beta naught plus beta 1 x. Now in this case it's not directly like that. Beta naught plus beta 1 x is also there, but it's given by p of x by 1 minus p of x. Or you can say it like in this way. So just wait a moment. So all those who have given like sigmoid of the dependent variable, sigmoid relationship is there, but that relationship is not between the dependent and the independent variable. Okay. So the answer here will be, now can you say the answer? Log of dependent variable? Not quite. I'm still getting A. Okay. So what I'll do is like, I'll take an example. Okay, just wait a moment. Okay, so just I've given the difference between linear regression and logistic regression. From the figure itself you can see that in logistic regression, if the x values are lying between these 2 points, if x values are given like this and y values corresponding to the x values is 0, it will be lying in this particular level. If it's 1, it is lying in this particular level. So the mathematics behind the logistic regression is like, we have to find a curve which separates these two values. Okay, so that's why we say that there is a sigmoid curve involved. Okay, I think this page is visible to you. So here you can see odds ratio is given by probability p of x by 1 minus p of x, I have already given, and this relation is log of p of x by 1 minus p of x is equal to beta naught plus beta 1 x. This is known as the logit function. And so if you say that the linear model was like, your linear regression model was like, a line would have been there and that line was defined by y is equal to beta naught plus beta 1 x. That is a linear model. Now in the logistic model, your line would be defined by p equal to, so just if you see this one, if you reverse it, okay, if you bring this particular log to the other side, it will become e raised to minus beta naught plus beta 1 x, right? So p of x by 1 minus p of x will be e raised to minus beta naught plus beta 1 x, and solving this particular equation for p of x will give you 1 by 1 minus e raised to minus beta naught plus beta 1 x. In other words, logistic regression outputs the probabilities of a specific class, and these probabilities can be converted into class predictions. So right now if you see, it's not directly the log relationship between the dependent and the independent variable, okay, and it's not directly the sigmoid relationship. The sigmoid relationship is there, but it is like, it's related with the probability, okay. So for that, because of that, I think you can just conclude that in logistic regression a linear relationship exists. So there is no linear relationship here, right? If you see the equation, it's not linear, right? So there is no relationship assumed, okay? Or you can say that, I mean, with these things, the linear relationship is not there. So you can say none of the above. And if you want to do something, if you want to give an answer for this one, in logistic regression, you can say that a linear relationship is actually assumed between the independent variable and dependent variable, okay? Because that is how we are starting the analysis, okay? In cases only where there is kind of a linear relationship observed only, we will be going with logistic regression for classification problems, okay? Otherwise we will be going for some kind of a log odds and dependent variable also, that you can say, yeah, kind of, but that is not like, actually that is not a relationship drawn, right? Because we'll be having dependent variables and independent variables only, right? You can say, I mean, just seeing the mathematical formula, you can say that such kind of a relationship will exist. But at the starting itself, what we'll be assuming that if your relationship is kind of linear, you'll be going with the basic regression or classification problem, which is logistic regression for classification and linear regression for regression problems, okay? If those cases are not non-linear, it's non-linear, you will go for other methods of prediction, okay? So a linear relationship will be assumed between the dependent and the independent variable. So I hope that's clear. So we'll move on to the next question. The confusion matrix for a binary classifier gives. This you can give the answer either A, B, C, D. So I've got the answer D. Option for D. So everyone is clear with that. You will be getting true positives for false positive, true negative, and false negative. That is true. Next one. So this is another course, okay? Just the first course. Which among the following is not a type of cross-validation technique? You can just read through that, or first you can, from your memory itself, you can say which is not a cross-validation technique. So I've got the answer D. Yeah, it's not cross-validation technique. So I think you all know leave one out cross-validation is like if you have a set of data like this, okay, and there are different sets of data, okay? In the first validation, one of the thing you will be taking as a test set and the rest of the thing you will be taking as a training set. So here in each observation is considered as the validation set, and rest n-1 observation are considered as the training set, that is leave one out, okay? One you will be leaving out for validation and the rest you will be taking for training, that is leave one out cross validation. Then k-fold cross validation is like it's used on a limited data sample. So there is a single parameter called k that refers to number of groups. When a specific value for k is chosen, it might be used in place of k, okay? So here it's like if k is defined, first k sets will be taken for validation and next things will be taken as training. Then this k will be repeated all through the data, okay? And then validation set approach is a type of method that estimates a model error rate by holding out a subset of data from the fitting process, creating a testing data set. So a separate subset of data will be there available as the validation set. Then the model is built using other sets of observation. Then the model result is applied on the testing set, which we can then calculate the error. That is the validation set approach. Bias variance trade-off is not a cross-validation technique. It is like a trade-off between the bias and variance. So this also you have seen in your lectures. So it's kind of like if the algorithm is too simple, or it is a hypothesis with a linear equation, that it will be on high bias. There will be high bias and low variance. This kind of thing is like error prone. Now if it fits too complex, Then hypothesis, that means with a higher degree equation, then it might be on high variance and low bias. In the latter condition is like overfitting condition, the new entries will not perform well. So there is something between both of these conditions known as the trade-off, or it's known as the bias variance trade-off. Okay, so this was explained with the help of one graph which showed the training error or the bias squared. Okay, similar kind of graph you have seen in your lectures. Then there is the variance, okay, and then there is the optimal solution which shows the trade-off. So here in this middle portion is the optimal case of the solution or optimal model present, where it's not leading to underfitting also, and it is not leading to overfitting also. Okay, so this particular place is where the better or optimal model exists. So here the total error, we can't say like that, Moti Gupta. Okay, neural networks, they are also like there are first layer and then you will have some kind of a linear okay, so it's like there will be a layer. First there will be layer, you'll be taking inputs from them, right? And then some kind of operation will be done, and this input into weight, it's like one input xi if I can give into weight plus bias, and again it will be passed on to a sigmoid graph. Okay, some sigmoid function will be given, sigmoid, I'll just represent it like that, and the output will be coming. So if it's just one layer of a neural network, that also is like a simple network only, just like a logistic regression. Now if many different layers are added, sometimes it will be like in this zone, it will be coming in this zone also. Okay, so we have to like train and see which is the optimal one. Even for neural networks also you can have an underfit model if you have less number of layers. Okay, so in cases where where your data is very variable, or your output depends on so much on all the different features that are present, then you will require more number of layers to solve the particular problem. Okay, so sometimes you cannot say that with neural networks your complexity is too high and variance also will be too high. That can't be said. Sometimes it will come in the optimal region itself. Okay, that you have to test and see. That's why you might be seeing different parameters. You'll be looking at train accuracy, test accuracy, then the errors for both the train and test sets and all. And one of the major things you have to see is that if the test accuracy is very low and the train accuracy is very high, then it means that your model is overfitted model. Okay, so that much complexity is not actually required. Okay, yes, so the total error here in this graph, so it's calculated like bias square plus variance plus irreducible error. Okay, so just a simple theory question: which among the following is a classification problem? I've got the answer 2, 4, B and D. Yeah, that's right. Predicting whether a patient is diagnosed with a disease or not, and whether it will rain or not tomorrow. I am not seeing any different answers, so we can go with this one. Yeah, so predicting whether a patient is diagnosed with a disease or not. Yeah, whether it will rain or not tomorrow. These are classification problems. Now consider the following confusion matrix, and you have to find the accuracy of the model. You can give in the answers. Got A. Yeah, I think it's already present. This question might already be present, right? Anyway, what we can do is, so n right now here is 55 plus 5 plus 0 plus 40, that will be giving 100, right? And Accuracy is defined as the true positive plus true negative by total number. So it will be like 55 plus 40, 95 by 100. So your answer will be 0.95. Okay, so I think you have got the answer. So for the same model you have to calculate next one, the sensitivity. So sensitivity also you can tell me the answer. Sensitivity I've got the answer as 1. Yeah, so for what was sensitivity? So in the total positive labels which were present, so total positive labels which were present will include true positive plus false negative, and Harshmodi false, not false positive, yeah, false negative, yeah. So true positive by true positive plus false negative, answer you will be getting like 1, that is true. So the answer here is 1. Okay, I hope that's clear with everyone. Under the family parameter of GLM function, which one of the following distributions corresponds to logistic regression for a variable with binary output? You can give the answer. You got the answer A. Any other answers? So just that for this one I got B. Okay, for this one I'll just go through this particular thing. Okay, so this is generalized linear model, GLM. Okay, so it's used to estimate regression models for outcomes following exponential distribution. In addition to normal distribution, these include all these things. Okay, so normally there will be Gaussian or normal distribution, so maybe that's why one of you have given B. But one thing you have to see is like binomial regression or for binary classification. Okay, it's binomial, you can see that here, right? For classification problems it is binomial distribution, so your answer here will be binomial. Okay, yeah, so answer is binomial. So I think for now these are the different things that we have had in the present week. Okay, two class problem is still two classes are only there, right? It's like binary, yes or no, or either one or the other two classes. It still be same, only for multi-class. If 1, 2, 3 options are there, then it will be changing. Okay, and for that you can look at this one. Okay, so there also you can say that a binomial error distribution will be followed. So because this particular data which is like empty cars, okay, that has different things. Okay, just wait a moment. Okay, so if you want to specify the family to be used, I mean by default it will be binomial, but if you want to specify it to some other family, you can put it differently. Okay, so just we will move on to another thing. So here I have given another thing just to see, because we haven't looked at some other things, right? So for that I'll just clear everything and okay, I'm just loading from this datasets library because iris dataset is already present in as inbuilt datasets in RStudio. So I'm loading from that, and if I just give iris loaded to that one, it will give you the iris dataset. Now head iris data will give you the first 6 samples, and str will give the structure. Okay, it's already loaded as a factor in the default datasets in the datasets library. Okay, so you don't have to read it as factor, it's already there given as factor. Then the different levels of the species column is given, like if you want to see like that, you can use the levels function, and if you want to find any missing values, we have already checked that. Now what I'm doing is like, first now I'm only checking 2 values. Okay, so it's like either so in this particular case it will be like 1 to 100. So first it is setosa, and then versicolor, and then virginica is coming. So the first 50 samples are setosa, and next 50 samples are versicolor. Okay, so what I'm doing is like, I just want to see 2 of the species, so I'm just putting like 1 to 100. Okay, earlier we had seen with the 3 classes itself, so I'm putting the seed value different here, 100. Okay, now just if I am sampling 80 samples from that, and I am putting it as training sample, and the rest I am putting as testing sample. So you can see that I have just taken 100 rows from that, and from that 80 was given as train sample. So you can see the dimension 85 as dimension of train set, and 25 as dimension of test set. Okay, now if you want to see, so this is like I have just given. Okay, if you are not installing through the environment, you can use this particular install.packages. Okay, so someone had used, right? So if you are not installing from this one, you can use install.packages, and if you can put dependencies equal to true. Okay, that will give you the installation with dependencies. Okay, so this is another method. Anyway, so I have included this package, and this package also I will include in the library. And if I say see the pair plot of this particular thing with 2 species only, I can see these graphs. Okay, so now clearly you can see here there is some skewness here, right? If when just 2 species were taken, this graph is showing some skewness. Okay, it's not directly normally distributed in this particular data. So what happens here is that in this particular data, okay, there is a variation. The sepal length distribution is different because here only setosa and versicolor is here. So every time you have to check the distribution. All right, okay, so now when we had taken just these two species, there is a skewness in the distribution. It is like right skewed. Okay, so not normally distributed. And anyway, both the other things are already not normally distributed. Now in this case, only the sepal width is kind of normally distributed. Now another thing, so sepal length is more normalized here. So then again I am putting y as the train species and x as the train sepal length, and just I am fitting that for a linear model. So in this thing I am just taking only the intercept as well as x, which includes the sepal length. Okay, so this can be given with respect, just now I have taken sepal length only. Okay, because with this one earlier I had seen it more normally distributed. You can use sepal width also, but just you can see how much significance is there for these 2 variables. Okay, like it's very significant. Okay, now so this is one of the things, and Then if you want to find out a new prediction, then you can use the predict function. Okay, so just if I do that and prediction value, predict of GL fit new data. So in the new data I have given the test set. Okay, and if I am running this and seeing the prediction, it will be coming like this. Okay, so in the prediction, in the test set, it is given like species is setosa and predicted value is coming like this. So we have to convert this prediction as either, I mean a threshold value is present, so either we have to convert it to either setosa or vesicular to compare them. Okay, so for that what I am doing is like, again I am taking it, okay, and I am storing it to a new pred new variable. Okay, the recorded video is already available in the Excel file, right? Yeah, I'll upload that. Okay, so anyway, so this will be uploaded. Yeah, so pred new, and so I've just given less than 0.5, less than or equal to 0.5 I'm giving as setosa, and greater than or equal to greater than 0.5 I'm giving as versicolor, and pred new right now in this one. Okay, so what I'll be doing is like I'll be forming a data frame, new data frame with sepal length. Okay, because we had formed our model with the help of that particular independent variable only. Okay, we have taken just that. And the next one is species and pred new dot pred type. Okay, so if I am forming like that, I'll be getting, so this is like, so if I just see that, okay, pred class right now which we have formed, you can see that the species is setosa, but it's not correctly classified. It's classified as versicolor. Another thing you can see is setosa. So there are many misclassifications here, right? Because we had just used one particular column only, or one particular feature only. So there are many misclassifications. Okay. Now, so I have seen the structure, okay, of that, and to have the confusion matrix I'll be installing the caret library. Okay, so example, okay, so it is slow. First when I'm seeing that pred class, pred new, okay, and reference as species, it's telling that the data and reference should be factors with the same levels. Okay, so since that thing is there, I'll be again changing them. Okay, so anyway, this is like just a plot again, so just you have to see them as a factor only, and then you can see the confusion matrix. Okay, if you run, so that is like right now which I formed, the data and reference are not factors with the same levels. Okay, so one thing is like, the problem is the species already have 3 factors. Okay, the error here is coming like this now, because the species have 3 factors which I've taken. So that you have to take into account. Same thing which you have used here itself, confusion matrix you can use here and see the difference. Okay, so I think this is all for today's class. Okay, just I'll check, since the question was asked, just I'll check the folder. Any other questions you can ask? So till week 6 actually everything is uploaded. Hema Bhargavi, So today's, yeah, I'll upload today. Caret library. Okay, that library. Okay, I'll just take. So it's actually called like, I'll just put that in the window just now. Okay, actually, so if you check in the package, okay, it's given like classification and regression training. I hope this is visible for you. So this package has different things. Okay, so as.matrix.confusion matrix will give you the confusion matrix as a table. Okay, so there are different things available there. Just I'll give you the share this particular window. Okay, so this is the caret package. Install.packages caret dependencies. If true, all the dependencies will be installed. Just I'll increase the size. Okay, so this is the caret package. Okay, known for classification and regression training, contains functions to streamline the model training progress. You can just check this particular web page. Okay, cran.r. okay, so in this particular library only, we use this library because we are trying to see the confusion matrix. Okay, so just a moment. So if you want to find the confusion matrix, okay, this is the function that you have to use. Confusion matrix data equal to from this one and testing underscore class. Okay, so if you do that, this you have seen in your lecture video also, you will get this particular value prediction and reference like this. Okay, so Gayatri ma'am, you have,
Yes, ma'am, I have one doubt, ma'am, actually.
yeah,
Uh, Ma'am, actually, this assignment they have given, if you could go through only the data sets, ma'am, I think they have included the serial number, but all the other questions remain the same. When you include the serial number, you will have 6 columns.
yes, yes, yes. So
Ma'am, you're
what is the
able to hear
difference?
me?
Yes, 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 I can hear you. Gayatri ma'am, I I think I've lost you for a moment there. So
Ma'am, you're able to hear me, ma'am?
yeah, yeah. Now you're audible.
Yes, ma'am. Sorry, ma'am. Actually, I have some glitch in the network. Ma'am, the assignment they have given the data set, ma'am.
Yes. Okay.
They have included the serial number.
Yeah, that is fine. I
So
mean,
it is,
which data set are you using?
ma'am,
I
same iris data set.
Okay, like this you might be getting, right?
Yeah, yes, ma'am. Yes, ma'am.
Yeah.
My doubt is whether we should include that ID also as a sixth column, or it is not necessary. It's only for reference.
It's not necessary. That's why in the beginning I have given, right?
Okay.
I have just given like row dot names equal to ID.
Okay. Okay.
So if I'm not giving that, then it'll
I
be
it's
taking,
showing one. Yeah.
yeah, it'll be showing that extra column also, but that is kind
Okay.
of an irrelevant column. Okay, it's not required for
Okay.
your modeling.
Okay, ma'am. That is why I asked whether we should include that or we should exclude. That's only my question, actually.
Yeah, it can be excluded
It
because
can be.
yeah, it's just like a serial number. It can be excluded.
Okay, okay. Thank you, ma'am. Thank you.
Okay. The availability of calculators, I think you have to ask in the discussion forum, okay, Mugda? Because I mean, you'll be getting new mails before the exams, so there you can just go through which all the resources given for the exam. What are all the resources? Okay. Any other questions?
Ma'am, any reference link is there, ma'am, for the R?
Whatever is needed in that particular module, I am just in that particular week, I am just putting there. Okay, so
Okay,
you
okay,
can
okay,
go
yes,
through
ma'am.
those links.
Yes, ma'am. Yeah, yeah, I for.
Yeah,
Okay, ma'am. Thank you.
yeah. Okay, so I hope everyone else is clear with everything. Okay. Okay, everyone, complete your assignments. Have a nice rest of the day. Thank you.